Hi guys, this is AS Chemistry, Organic Chemistry, and we are looking at carbonyl compound. Question 7. Ketones are widely used as solvents and as intermediates in the chemical industry. Ketones contain the reactive keto group, which is C double bond O group attached to different or similar R groups or alkyl groups. Propanone, which is CH3, COCH3, here the two R groups are CH3, undergoes a reaction with hydrogen cyanide. So hydrogen cyanide is HCN, and the reaction that this would undergo would be a nucleophilic addition reaction. So that is exactly what is asked. What type of a reaction is this? It is nucleophilic addition. What reagents are used? So the reagents that are used would be HCN plus NaCN plus HCl. So these are the three reagents that would be required in order to carry out the nucleophilic addition reaction of propanone. Draw a diagram to show the dipole present in the propanone molecule. So CH3 single bond C, which is double bonded to oxygen, which is single bonded to another CH3 group. And the dipole present would be a partial negative charge on the oxygen atom and a partial positive charge on the carbon atom. So this is the dipole that is present on propanone. Propanone reacts with 2,4-dinitrophenyl hydrazine reagent, the structure of which is shown. Construct a balanced equation for the reaction between propanone and 2,4-dinitrophenyl hydrazine. So the propanone molecule is C double bond O, and it is attached to two CH3 groups. And this would react with 2,4-dinitrophenyl hydrazine, which would be this molecule. And this particular reaction is a condensation reaction because the water molecule that is removed is the oxygen of the carbonyl group and the two hydrogens of the NH2 group. This is the water molecule that will be removed, and the product formed would have the C of the carbonyl group forming a double bond with the N of the hydrazine molecule. So this is the product that is formed, and the water molecule that is removed is the other product that is formed during the condensation reaction shown here. So this is the reaction equation for the condensation of propanone with 2,4-dinitrophenyl hydrazine, forming the product which is represented as a yellow-orange precipitate. A similar type of reaction occurs between propanone and hydroxylamine, which is NH2OH. Draw the displayed formula of the organic product of this reaction. So here, the water molecule removed would be the two hydrogen atoms of the NH2 group and the oxygen atom of the carbonyl group. So the product formed here would be carbon atom attached to the two CH3 groups and a double bond with a nitrogen atom which is attached to an OH group. And we would also have a water molecule which was formed during the condensation reaction. Question 8. Give the structural formulae of the two aldehydes formed by the partial oxidation of the unsaturated fat below. In the structure, X represents the rest of the fat molecule. So, oxidation of this compound would result in breaking of this double bond, which would result in the formation of two compounds. And since it is the aldehyde that we need to show that is formed, so one of them would be CH3, CH2 repeated 7 times, and then we would have CHO. And in the other molecule, we would have a CHO where the double bond broke. We would have CH2 repeated 7 times, and then we would have X, which is the rest of the fat molecule. So these are the two aldehydes formed by partial oxidation of the unsaturated fat. Name the reagents you would use to show that the product contains either an aldehyde or a ketone. What change would be seen? So the reagent would be 2,4-dinitrophenyl hydrazine, and the observation would be formation of a yellow orange precipitate. This would be a positive test for the presence of a carbonyl compound. What reagent would you use to confirm the presence of an aldehyde? What change would be seen? So the reagent we would use for the confirmation of an aldehyde can either be a Tollens reagent, in which the observation would be formation of a silver mirror, or we have formation of black precipitate. And the alternative to this would be using Felling's reagent, and the observation that we would get with Felling's reagent would be formation of a brick red precipitate. Question 9. The compound trans 4-hydroxy 2-nonenal, which is HNE, is thought to lead to infections of the lung when cigarettes are smoked. The skeletal formula and the condensed structural formula are shown. Give the structural formula of all of the carbon containing compounds formed in each case when HNE is reacted separately with the following reagents. And the reagent is sodium tetrahydroborate 3, which is NaBH4. So NaBH4 is a mild reducing agent. So what would happen is that the aldehyde group present on the right side of the compound would be reduced to a primary alcohol. So considering the condensed structural formula, we will have CH3, CH2 repeated 4 times. Then we would have a CHOH group, which is a secondary alcohol group. Then we would have a CH double bonded to another CH, which will not be affected by the presence of NaBH4. But the CHO group would be converted into a CH2OH group, which is a primary alcohol. And that is what is formed when an aldehyde undergoes a reduction reaction. Question 10. Astronomers using modern telescopes of various types have found many molecules in the dust clouds in space. Many of these molecules are those of organic compounds, and astronomers constantly look for evidence that amino acids such as aminoethanoic acid are present. One molecule that has been found in the dust clouds is hydroxyethanol. Hydroxyethanol contains two functional groups. Name as fully as you can each of the functional groups present in hydroxyethanol. So, ethanol means it has the presence of an aldehyde group, and hydroxy means it has the presence of an alcohol group. But since the formula is CH2OH, this is a primary alcohol. For each functional group, identify a reagent that will react with this group and not react with the other functional group present. In each case, describe what would be observed when this reaction is carried out. So the first functional group mentioned is an aldehyde group. So in order to test for an aldehyde group, we would use Tollens reagent. and we would have formation of a silver mirror or a black precipitate, and this would be a positive test for the presence of the aldehyde group. As for the alcohol group, we can have addition of sodium metal, which would result in effervescence. And this effervescence would be for the hydrogen gas produced. We can also have for the alcohol group addition of PCl5, which would give steamy white fumes, which would be the fumes of HCl that is produced during this reaction. Give the skeletal formulae of the organic compounds formed when hydroxyethanol is reacted separately with the following. So the structure of hydroxyethanol is HO, CH2, CHO. So when it is reduced using NaBH4, the aldehyde group is converted into a primary alcohol. So the compound becomes HO, CH2, CH2, OH. So the skeletal formula of this compound would be, we have two CH2 groups, each attached to an OH group. So this is the skeletal formula of the product of the reaction of hydroxyethanol with NaBH4. And then we have acidified K2Cr2O7 and under reflux conditions. So this would result in the oxidation of the aldehyde into a carboxylic acid and the oxidation of the primary alcohol group into a carboxyl group as well. So the product of this reaction is COOH and COOH. So in order to form the skeletal formula of this compound, we would have two carbon atoms, each forming a double bond O and a single bond OH group. So this is the skeletal formula of the product of the reaction of hydroxyethanol with acidified K2Cr2O7 and heated under reflux. In a school or college lab, it is possible to convert a sample of hydroxyethanol into aminoethanoic acid in a three-step process. So aminoethanoic acid has a COOH group in place of the aldehyde group. That means the aldehyde was oxidized. And it has an NH2 group in place of the OH group, which means the OH group underwent nucleophilic substitution. And the OH cannot be directly replaced by the NH2 group. OH first has to be replaced with a halogen, and the halogen must be replaced by the NH2 group. So one of the steps would be replacement of OH with a halogen. The next step would be the replacement of the halogen with the NH2 group. And the third step would be the oxidation of the CHO group into the COOH group. By considering the possible reactions of the functional groups present in hydroxyethanol, you are to decide a possible route for this conversion. In the boxes below, draw the structural formula of your suggested intermediate X and Y. So X should be OH replaced with Cl, so Cl, CH2 and CHO, and intermediate Y would be Cl replaced by NH2, so NH2, CH2, CHO. State the reagents for each of the three steps you have chosen. So the reagent for the substitution of the OH group with the Cl group can be PCl5. So when we react the primary alcohol with PCl5, we end up with the OH group replaced by the Cl group. And in step 2, we've got replacement of the Cl group with the NH2 group. So this would be ammonia. So ammonia would replace Cl with the NH2 group while producing HCl as a byproduct. And in step 3, we have oxidation taking place. So, oxidation of aldehyde would be carried out in the presence of acidified K2Cr2O7 and heat under reflux, or we can have acidified KMnO4 and heat under reflux. No conditions required for the reaction with PCl5, but the conditions for the reaction with ammonia would be requiring heating under pressure. But they have not asked for the condition, they've just asked for the reagent. So step 1 requires PCl5, step 2 requires ammonia, and step 3 requires acidified K2Cr2O7. Question 11. Each of the three organic compounds V, W, and X has the empirical formula CH2O. The number of carbon atoms in each of their molecules is shown in the table. Okay, 1, 2, and 3. V gives a brick red precipitate when warmed with Felling's reagent. W and X do not. So V is an aldehyde and W and X are not aldehyde. W is a fruity smelling liquid. If it's a fruity smelling liquid, it has to be an ester. And in X, the carbon atoms are bonded directly to one another. So it is unbranched. X gives an effervescence when shaken with Na2CO3, V and W do not. So it is an unbranched carboxylic acid. Give the structural formula of V. So a single carbon containing aldehyde has to be HCHO, which is also known as methanol. What functional group is present in W? The functional group present in W is an ester group. And give the structural formula of W. So since we have two carbon atoms, one of them is part of the carboxylic group. That means the other has to be part of the alcohol group, because we cannot have a hydrogen attached to O, that would make it a carboxylic acid, which means the carboxylic acid used in forming this ester is methanoic acid. So it would be HCOOCH3. When X is heated under reflux with acidified K2Cr2O7, the product Y gives no reaction with 2,4-dinitrophenylhydrazine. That means X undergoes oxidation but does not form a carbonyl compound. That means X also contains a primary alcohol group other than the carboxylic acid group. So give the structural formula of X. So we have three carbon atoms. One of them is the carboxylic group that is present, and all carbon atoms are linked in a straight chain. So we would have a CH2 group here, then we would have another CH2 group attached to an OH group, because this is the primary alcohol that will be oxidized to a carboxylic acid, which would not give a product or a reaction with 2,4-dinitrophenylhydrazine. And give the structural formula of Y, the compound formed from X. So that would be COOH in place of the primary alcohol, a CH2 group in between, and then another COOH group. When X is warmed with a little concentrated sulfuric acid, a small amount of a cyclic compound Z is formed. Z has a molecular formula C6H8O4, suggests a discrete formula of Z. So X has a carboxyl group and an alcohol group present. So if we have two molecules of X together, we would end up with the OH group of one molecule reacting with the C double H group of another, and the C double H of molecule 2 reacting with the OH group of molecule 1. So in this way, we have the formation of a cyclic diester. So they're asking us to suggest a displayed formula of Z. So for this, we would need a C double bond O group of one molecule of X. Then we would have a CH2 group. Then we would have an OH group of the other molecule bonded to the C double bond O group of the second molecule, a CH2 group bonded to an oxygen atom of the first molecule. So this is the cyclic diester that would form. The only thing that is incorrect in this structure is this molecule has two CH2 groups present. So instead of one CH2 group, we would mention two CH2 groups for each molecule. So redrawing the structure, we would have CH2, CH2, and CH2 and a CH2 for the second molecule as well. So this is the structure of the cyclic diester Z that would form. What type of a reaction occurs when Z is formed from X? This reaction is known as an esterification reaction. Question 12. Organic compounds which contain oxygen may contain alcohol, aldehyde, carboxylic acid, ester, or ketone functional groups. The functional groups may be identified by their reactions with specific reagents. Compound X has the empirical formula CH2O and NMR of 90. There is no reaction when X is treated with NaHCO3. So that means it is not a carboxylic acid. What functional group does this test show to be not present in X? So the group that is not present is a carboxylic acid group. When 0.6 grams of X is reacted with an excess of sodium, 160 cm cube of hydrogen measured at room temperature pressure is produced. What functional group does this reaction show to be present in X? So this is the test for the presence of an OH group. And since the carboxylic acid group is not present, so reaction with sodium metal would mean that the OH group is present and it is not part of a carboxylic group. So it has to be part of an alcohol group. Use the data to calculate the amount in moles of hydrogen atoms produced from 0.6 grams of X. So the volume of hydrogen gas produced is 160 cm cube. So the number of moles of hydrogen gas molecules would be equal to 160 divided by 24,000, which would give us a value of 6.67 into 10 to the power of minus 3 moles of hydrogen gas. And what is needed is moles of hydrogen atoms. So number of moles of hydrogen atoms would be 2 into 6.67 into 10 to the power of minus 3, which gives us a value of 1.33 into 10 to the power of minus 2 moles of hydrogen atoms, because each molecule of hydrogen contains two atoms of hydrogen. Hence, show that each molecule of X contains two of the functional groups we have given in one. So the moles of X that we have would be calculated by dividing 0.6 grams of X with its MR, which is 90. This gives us a mole value of 6.67 into 10 to the power of minus 3 moles. These are the moles of X that are present in the given sample. So now we have moles of X present, and the molar ratio of X, so moles of X is to moles of hydrogen atoms would be 6.67 into 10 to the power of minus 3 is to 1.33 into 10 to the power of minus 2. So in order to find out the ratio of hydrogen atoms present, we would have moles of X and moles of hydrogen atom each divided by the lower value, which is 6.67 into 10 to the power of minus 3. So we end up with a molar ratio of X is to H atoms of 1 is to 2. So since there are two hydrogen atoms present for each molecule of X and the hydrogen atom would be part of the OH group, that means two OH groups are present in each molecule of compound X. When X is bound with Felling's reagent, a brick red precipitate is formed. That means we have presence of a carboxylic group. Treatment of X with 2,4-dihydrophenylene hydrazine reagent produces an orange solid. So same, it's a carbonyl group. What functional groups do these reactions show to be present in X? Draw the displayed formula of the functional group. So this proves that an aldehyde group is present. So RCHO group, which is the aldehyde group that is present in compound X. Use your answer to B1, 2, and C1 to deduce the structural formula of X. So the molecular formula of X has a mass of 90 and we have an aldehyde group present and we have got two alcohol groups present in a molecule of X. Also, the molecular formula of X is CH2O. So if we have CH2O as the molecular formula, the MR is 90, we have presence of one CHO group and two OH groups, which would be attached to carbon atoms. So in total, we've got three oxygen atoms present, which means we would have three carbon atoms present. So in order to form this formula, we will start with the aldehyde group. That will be the first carbon atom. Then we would have two other carbon atoms, and each carbon atom has to have a bonds with the OH group because there are two OH groups present. So this is the structure that we have come up with, and in order to finalize whether the structure is correct or not, we will calculate its molecular mass. So that would be C3 12 into 3, which is 36. Then we have oxygen also 3, so 16 into 3, which is 48. And we would have the number of hydrogen atoms present as 1, 2, 3, 4, 5, 6. So 1 into 6. So a total of 36 plus 48 plus 6 gives us a value of 90. So the MR of this compound is 90, which means that the formula that we have made is the correct formula for compound X. What is the structural formula of the organic product of the reaction of X with Felling's reagent? So when X reacts with Felling's reagent, the aldehyde group is oxidized to a carboxylic group. So the alcohol groups would remain as they are, but the CHO group would be converted into the COOH group. So this would be HO, CH2, CH, OH, and then COOH. So this is the product upon the reaction of compound X with Felling's solution. Compound X can be both oxidized and reduced. Yes, because alcohol groups are present, they can be oxidized, and an aldehyde group is present that can be oxidized as well as reduced to a primary alcohol. Give the structural formula of the compounds formed when X is reacted with NaBH4 under suitable conditions. So the aldehyde group would be reduced to a primary alcohol, which would mean that the two OH groups present remain as they are, attached to a CH2 group and a CH group, but the CHO group is converted into CH2OH. So this is the product upon the reaction of compound X with NaBH4. Give the structural formula of the compound formed when X is heated under reflux with acidified K2Cr2O7. So the primary alcohol group on the left, CH2OH, will be converted into COOH group. The secondary alcohol group in between the CHOH group will be converted into a C double bond O group, and the aldehyde group on the right will be oxidized to a carboxylic acid group as well. So this is the structure of the product upon oxidation of compound X in the presence of acidified potassium dichromate and heating under reflux.